So what is usually done is that the actual implementation of the lock with this specific interface that I chose, I just said, for my needs, it would be nice to be able to create new lock, all right, create an object, which I call critical section, which really makes this part over here critical section, right? So we can say that once we obtain the successfully this lock, we can say that critical section begins. Critical section of what? Critical section of the code, right? Critical section begins, right? And when we say release, we say that critical section ends over here, right? So that's where the critical section ends. So this is our management of basically this being a critical section of code that we would like to protect from concurrent access from multiple threads, because we don't want to incidentally expose an instance which is null to two threads at the same time. We always want to make sure that that this section is protected, and that only one thread of execution who will be the winner of that initial lock, that only that specific thread will be able to say new singleton only once per application lifetime. So, but with this simple idea of a lock and lock creation and lock release, usually what developers do is that they usually, because synchronization requirements, multi-threading requirements could vary from system to system, from platform to platform, from performance requirements, on one platform and different platform. What needs to happen is that usually implementation of the lock is isolated into yet another class, right? So this is going to look a little strange. What I'm going to do is to say, first of all, the lock itself, if you think about this, right? So we have this two threads of execution and potentially one user and another user trying to do the same thing at the same time, which is very typical, right? So this idea of a lock to prevent creation of singleton, by multiple threads, what needs to happen is that this lock, an idea of lock, has to rely on another static piece of data. Somewhere here, there needs to be a static object which represents the actual locking mechanism, right? So that they both, when we say get instance, they both go to this object and they both begin to talk with this object. However, I would like to isolate this detail of this one object by instead of doing all this low-level conversation at my get instance level. By the way, I may need my locking to be done in multiple places, and I may want more critical sections in my entire application. So I want to isolate this into, make it invisible to this high-level code where I manage my critical sections. And over here, all I want to do is just basically create new lock and release it, okay, and let it go. So therefore, what I'm going to use over here as basically my platform, I'm going to say static, right? It's static. It's this object lock which will talk to this unique object. And by the way, I also have a name for it as well. I will call it a mutex, right? Mutex. Basically, mutex will be, so this box right here, this object in memory, is an instance of mutex. And mutex is essentially an abbreviation of mutually exclusive access object, which pretty much what I'm dealing with. And I need to obtain the actual mutex from the system. And what I'm going to say, it needs to be static, right? Because we want only one instance in the entire world, right? And we're going to say static, it's going to be private, I think, right? Private static, and this new data type is going to be a mutex, right? Mutex, and I'll call it mutex right here, and I will say new mutex. Mutex. I will just create it. So I will introduce yet another class which will insulate the entire implementation of this critical section in yet another layer. So over here what I'm going to say is that because new mutex is created immediately as the application starts, I'm just saying here static instance name mutex, new mutex. I will add this class in a second, but what I would like to do in my lock is I'm going to say mutex acquire, right? Mutex acquire and mutex release, right? So again, this would be difficult to manage. This seems to be pretty simple, right? So I have an object named mutex, and right here, this is where I have it on my diagram, right? So I make it static, right? I will create this class and I will implement this class. But I would like to manage the actual locking mechanism through the constructor of the lock and through the method named release. Because I don't have destructor in Java, I just want to explicitly call release and say release. So these three pieces, the unique instance of mutex right here, its acquire attempt and its release attempt, these three pieces are best managed by this lock class, which I can again use just like this in my get instance. Basically say my entry point into the critical section is simply saying new lock, and my exit out of critical section is by saying release. Okay, so let's take a break at this point, and we will continue on after the break as we move to a different room.